Good evening to everybody. Please type your name, all of you. So last we discussed about the factorial we started, means, or you can say real permutation combination is getting started. So let's get started with this. So factorial, what we discussed, that ki n factorial always equal to n into n minus 1 into n minus 2 into so on till 1. The best way to remember is that means this way writing is sometimes difficult, so you can write n factorial, start from 1 and terminate till 1 n. This is what the meaning of this. So you can say n factorial will be divisible by every integer from 1 to n, because all the integers are available. You can easily mention that n factorial is always divisible by all natural number from 2 to n. It's divisible by every natural number 2 to n. It's always divisible. So because this is containing all kind of the natural number from 1 to n, that's why it's divisible by every natural number. So this is I hope factorial everybody understood. It's not a very big thing. It's a very small things. 1-2 questions we'll do, and let me see that you are able to answer quickly, so that we can move further. Question is in front of you. Whatever your answer, please type quickly, very fast. Time is not that much. The last 2 digit in this number, 1 to 100, k factorial, means 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial, so on till k factorial. What will be last 2 digit? Very simple question. You have to use common sense. Last 2 digit. Little bit fast, you have to answer. I did not get anybody's answer. Quickly answer, everybody. Very, very simple question. Only one student given till now correct answer. Factorial. See how Means you are not able to solve factorial question. Just you have to tell me what will be last two digit. Okay, check it here. The last two digit in this first thing, what is the number? Number is your 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial plus so on. 5 factorial plus 6 factorial plus 7 factorial and so on till 100 factorial. This is your number. Of course, it's a very big number. We cannot calculate everything. Last two digit, you know that the numbers is increasing. We have to see that till when the last two digit is not going to be 0. So think carefully. This value is 1. This I'm doing manually. Without this also you can do. 2. This will be your 6. This will be a 24. This will be 120. Am I right? This will be 720. And this will be what? 7 into 720. 7 into, because 7 factorial, we can, because once is bigger, you have to change it into 120. So that will become 0 and 744, 1. And this is the 840. Sorry, something wrong I'm doing. Yes, 840 plus 8 factorial. 8 factorial, 8 into that. And that will be also 8 into 840. I'm not writing 9 factorial. Will be 9 into 8 into 840 plus 10 factorial. Yes, 10 factorial onwards is not a problem. Why so? Because that will be 10 into 9 into 8 into 840. So think carefully. This number having last two digit 0, so we can ignore it. And further, every number will have last two digit 0. If I ask you, what is the last one digit of this number? So you will say, okay, this is all this number. I can ignore all this term because last one digit I want, so this will not give the any effect. Only this will matter. The same way, last two digit. So till the time last two digit is not coming 0, we have to count it. So last two digit 0 start from 10 factorial. From here, we can tell oral also. We don't have to do manually. But right now, I didn't come to that point. That's why I'm not telling you that. 10 factorial will contain last two digit 0. Above something is there, I don't know. So here onwards, we have to check it out. So think carefully. Here last two digit will be what? This 9 into 8, 72 and 72 into 840. Total multiplication is not required. Only thing last two digit will be, I think it will become 80. Yes. Yeah. This is the 80 it's going to be. Here last two digit 80. Here last two digit will be what? 20. Here last two digit 40 already there. Here last two digit 20. Here last two digit 20, 24. And then you have to add it 30, 33. So 33 plus 20. Here it will be what? 100. These two become 100. Summation become 100, to leave that. Here summation become 80 and 80 plus this, you can add it, and this is going to be, I think, yes, the last two digit will be 113. Sorry, 13. I hope everyone understood the things. Right? So whenever you have to do the things, last two digit you have to calculate. So it means that ignore those terms which is the having last two digit 0. That's why I ignore 10 factorial onwards. Where is the mistake? Some mistake I did. Some mistake. Some calculation mistake maybe I can do. Okay, I will re-explain. Maybe I did some mistake in hurry. Check it here. What exactly I'm trying to tell you. Last two digit we have to get it for this number. Last two digit. The first thing is that 10 factorial will be what? 10 into 9 into 8 into 7 into 6 into 5 into 4 and so on. So this will contain 100%, 10 factorial will be 100% will contain last two digit 0. Further something else will be there, I don't know, but last two digit 10 factorial will contain 0. So after 10 factorial, every term will contain last two digit 0. Minimum two digit will be 0, last two digit. So that 10 factorial onwards I can remove. So capital X I can say 1 factorial plus 2 factorial plus 3 factorial plus so on till 10, 9 factorial only. Right? So from here what we can say, till here everybody understood? Why I am ignoring from 10 factorial onwards? Because there that number is the double zero already there. But if I'll ignore this question, if I write 1, 2, 3 plus 1200 plus 1, 2, 3 double zero plus 5 double zero plus 7 triple zero 4 times 0. If I say find out last two digits, what you will say? This term I will ignore because this is not going to affect. This is also not going to affect. This is also not going to affect. This is also not going to affect. So last two digits of this total summation will depend only on 1, 2, 3. So that will be 23. Same thing. In this case, what's happening? 10 factorial containing last two digit 0, 0. So 10 factorial containing 0, 0. So 100% 11 factorial also will contain last two digit 0, 0. Because 11 factorial is nothing but 11 into 10 factorial. Similarly, every number after 10 factorial will contain double zero at the end. So I can ignore those. I can keep only this much. And this you can check it manually what is going to be happen. 9 factorial will be something, we'll write it 1 factorial 1, 2, and this will become 6, 3 factorial 6, and 4 factorial 24, 5 factorial 120, 6 factorial 720, 6 factorial 720, 7 factorial will be 7 into 720. I may do calculation mistake in the previous when I was solving. And 8 this is 1 factor 2, 3, 4, 5, 6, 7. Yes. 8 factorial will become your 8 into 7 into 120. And 9 factorial 9 into 8 into 7 into 120. Full calculation, no need of doing. Think very carefully. This, what is the last? We need only last two digit, nothing else. Last two digit of this will be what? This you calculate. This is also last two digit. Here also last two digit. And then summation, you will get the answer 1, 3. Is it clear to everybody? Calculation you need to do. Right? Let's going ahead. Is this clear? Those who did not understand previously? Last two digit. We can do by other way also, but I didn't teach you that point. That's why I'm not speaking that. We have to neglect 10 factorial to 100 factorial because their last two digits is 0. Let's see one more question. 2, 3 more question I will do so that it should be clear. Yes, this question. Everyone, quickly. What will be answer? All question logic is named. Oh, no. One person given answer, but it's wrong. How is it possible remainder can be 33 if you're dividing by 20? Remainder is always less than the quantity which you are dividing. Yes. Check it here. First thing, 20. When 20 will come, 5 factorial is your 5 into 4, means 20 is coming in factor. So if in 5 factorial 20 is a one of the factor, so 6 factorial also will be 20 will be one of the factor. Yes or no? By 20 is 5 into 4. So who is divisible by 5 as well as 4? 5 factorial divisible by 5 as well as 4. 6 factorial divisible by 5 as well as 4, because I told you n factorial always divisible by 1 to n any number. So 4 factorial, if I'll take 4 factorial, this is divisible by either 2, 3, 4, but it's not divisible by 5. But I want the number which is divisible by 5 as well as 4. So first number what I will get, 5 factorial. This is divisible by 5 as well as 4. 6 factorial divisible by 5 as well as 4. Have you understand? Suppose if I say, what is the remainder when I divide 2 plus 25 plus 120 plus 625 by 5. So will you do addition? No. We'll say that this is divisible by 5. So neglect it, because this will give remainder 0. This will also give remainder 0. This will also give remainder 0. And when I will divide this, so remainder will be 2. Am I right or not? The term which is already divisible by the number, we can ignore. I'm now think very carefully in this. I'm dividing 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial plus 5 factorial plus 6 factorial plus so on till 49 factorial by 20. And I want to see what is the remainder. The first thing is that from 5 factorial onwards, I will ignore, because they will give remainder 0, because they are divisible. Only we have to consider this. It's very simple now. 4 factorial will be 24, 24 plus 6, 30, 30 plus 2, your, how much? 32, 30, 33. So this is the actually 33 by 20. So remainder will be what? Remainder will be 30. So answer will be A. A option will be answer. I hope it's clear to everybody. Everybody is not able to tell answers. Answers are coming. Very low number of people are giving the answers. If you don't understand, please mention. I will re-explain. But don't think, sir, divisibility question is a very simple. It will be used in the questions. If you want to really do JEE question, you should know all this thing. Only one fundamental key, n factorial always divisible by all the integers from 2 to n. This is the only fundamental I'm using. Next. This question, please, everybody. Let me see how many people can answer this question. This question, everybody. If you're not giving this answer, somebody have difficulty. Okay, I will re-explain. Anybody else? Those who did not understand, please let me know. I will be re-explaining, but make sure it's clear. Answer for this question, Arey. Still so many people didn't give the answer. Somebody want me to re-explain this part. I'm just doing the things. Please watch it. This, anything, if I ask you remainder, it means we have to ignore those number which is divisible by that. If A is divisible by B, and then remainder by of A by B will be 0. Remainder of A by B will be 0, because when you divide A by B, it will become 0 because this is the divisible by B. If I say what is the remainder of, if A is divisible by B, what is the remainder of A plus 2? I'm assuming that it is the big number. Just a minute. A plus 2 by B. What is the remainder when we divide this one? So we'll say this will be equal to A by B plus 2 by B. This will give remainder 0. And whatever this will give remainder, that will be answer. So 20 we are dividing. So remember, 20 factor is what? 5 into 4. So I have to check which are the numbers in this which is divisible by 5 as well as 4. So 5 factorial divisible by 5 as well as 4. 6 factorial then also will be divisible, because 6 factorial means it's divisible by all the number from 1 to 6. So it will be divisible by this also. So I can ignore from 5 factorial to 49 factorial. So basically answers will be 1 plus factorial plus 2 factorial plus 3 factorial plus 4 factorial plus 5. That's all. So further, it's already divisible by 20. So by 20, just divide it and check what is the remainder. I guess it's clear to you now. The person who asked that out. Now, this question, I think you should not use pen paper also. If you are dividing by any number, n factorial divisible by all the number from 2 to n. So this will give you remainder when suppose the number I am taking x. X is between 2 and n. X is between 2 and n. So n factorial plus 1 by x I am doing. If you divided n factorial by x plus 1 by x, n factorial by x will give you remainder 0. Why so? Because this is the divisible by every number from from 1 to n. This remainder will be what? 1. So finally answer will be 1. I hope it's clear to you, everybody. Right? So this was the talk about the factorial. Let's get started with the further things. Now, why we learn the factorial? Because calculation used to be very heavy in the permutation combination. So in place of writing 1 into 2 into 3 into 4, we used to simply write in term of the 4 factorial. So it will be easy representation, nothing else, no other purpose of the factorial. Factorial is the just a expression representation, big expression we are writing by the simply by factorial term. So now going further into this, now I will be further study we will be doing. I will be dictating as a note some points and I will explain the same time. Okay, so first point, everybody write it. Number of ways to arrange n different objects taking all at a time. See, everything, there is no theory, there is no formula in permutation combination. It's a kind of question. So what are the different type of situation? I will make as a cases and explain to you. First, treat simply as a question. I have to see that in how many different way I can arrange n different object taking all at a time. Meaning, suppose if I am having the digit 1, 2, 3, 4, stop writing and concentrate. I want to arrange all these 4 digits, taking all at a time. Means every object arrangement is taking place. Are you able to understand? So what is the possibility can be happen? I can arrange this way, or I can arrange this way, or I can arrange some other way. Like this, so many cases will come. So what actually permutation combination say? Arrangement means identify how many object, 4 object. How many object you have to arrange? 4 object. Whatever number of object you have to arrange, that many number of places I will draw. Arrangement means identify number of objects and that many number of places you draw and fill these places. That is the best way to do. So this place I can fill by 4-way, this place I can fill by 3-way, this place I can fill by 2-way, this place I can fill by 1-way. So answer will be 4 into 3 into 2 into 1. Yes or no? So now, in this case, there are the n different objects. How many objects you are arranging? I am arranging only, taking all at a time. All the object I am arranging. It means we have to arrange n object. So how many places will be there? N places will be there. How many places? N places will be there. So first place I can fill by n ways. Second place, n minus 1 way. Why n minus 1? Because repetition I did not mention. So it means repetition will not be allowed. This place I can fill by n minus 2 way. Means first place n way, second place n minus 1 way, third place n minus 2. So nth place 1 way. Yes or no? The total number of way will be n into n minus 1 into n minus 2, so on till 1. Means that is nothing but n factorial. So what is the answer will say? Will be n factorial. Have you understand? The actual meaning of the n factorial is what? It's an arrangement of n different object. See, this question I'm not doing. This question you can also do. I'm just trying to tell you meaning of n factorial. N factorial meaning now we can understand this way. It's an arrangement of n different objects. That's all. If anybody asking what actually n factorial, we'll say it's just arrangement of n different objects. Am I right? Now imagine carefully, everybody. Suppose there is the one place and one human is there. This name is Chanku. Right? In how many way I can arrange? Only one object. Only one way I can arrange. This is the only arrangement. Yes or no? If only one object is there, so only one arrangement can be done or not. So it means 1 factorial will be 1. 1 factorial will be 1. Because arrangement of one object is the only one way. If I say there is no object, there is no object. How many different arrangement, how many different look? Arrangement means looks. How many different looks you can create? If you are having 2 letters A and B, how many different looks you can create? You can create AB or you can create BA. Do not think, sir, I will create this way. BA. So many gaps. See, different look is coming. In the permutation combination, this you cannot create different look by distance. So this is also BA, this is also BA. So both arrangement will be considered as the same one. Understood? So 2 look you can create. Only one object is there, only one look I can create. If no object, blank. So blank is the only way. That's all. It means 0 factorial. Means arrangement of 0 object will be 1. What 1? That blank look, that blank arrangement is the one. That is the reason why 0 factorial is 1 as well as 1 factorial is also 1. Am I clear? Right? So this is the first point what we understood, that n factorial different object taking all at a time will be n factorial. Next point. Quickly, everybody. Number of arrangements of n different objects taking all at a time when repetition is allowed. I hope answer you can tell oral. Speak out. What will be answer? If you are arranging n different object and taking all the object at a time, repetition is allowed. If repetition not allowed, it's an n factorial. Very clear. If repetition allowed, what will be answer? Take up example and decide. Yes. If I say A, B, C, D, taking all, I have to arrange. It means 4 places. When I said all, means 4 object we have to do arrangement. A repetition allowed. So this place can be filled by 4-way. This place also can be filled by 4-way. This place also can be filled by 4-way, 4-way. So 4 power. So will be n power n. Again, I'm saying you don't have to learn this. You should know that this kind of situation can come. That's only purpose, nothing else. Next point. Number of arrangement of n different objects. Number of arrangement of n different objects is there. Taking, my writing is very poor, so please excuse for that. Taking r objects at a time. Taking r objects at a time. At a time. Understand difference. Nothing has to be learned. Just understand difference meaning. Now we have to arrange n different objects, but we are taking r objects at a time. R objects at a time. We are assuming that R is less than or equal to n. Means every object I am not taking. I am taking only few objects. How many objects I am taking? R objects. R objects means we will make R places. How many places? R places we are going to make it. Watch very, very carefully, everybody. So first place I can fill by n way. Second place I can fill by n minus 1 way. Third place n minus 2 way. Total R places is there. Fourth place n minus 4 way. Sorry, 3 way. Sorry, n minus 3 way. First place n, second n minus 1, third n minus 2, fourth n minus 3, fifth n minus 4. Tell me, 100th place, everybody type the answer. 100th place will be filled by how many way? First place n, second n minus 1, third n minus 2, fourth n minus 3. 100th place will be filled by how many ways? 100th place we can fill by how many ways? 100th place. Fast answer. First place n way, second place n minus. Yes, I guess everybody guessed correctly. N minus 99. And this is the rth place. And this is the rth place. So this place will be filled by n minus r minus 1 r naught. Everybody agree with me? N minus r minus 1. Or you can say n minus r plus 1. So total number of way will be what? N factorial, n into n minus 1 into n minus 2 into n minus 3 into so on till n minus r plus 1. Is it n factorial? No, because n factorial only I can say if it's going to terminate at 1. It's terminating here. But I want to write the answer in terms of n factorial. So what I will do, I will complete the session. This next term will be what? N minus r. Wait, 1 unit decrease. Na? Next term will be what? N minus r minus 1. And so on till 1. This is the extra I am multiplying from my side. So I must divide that. I must divide that. So n minus r minus 1 and so on till 1. Up now, easily you can understand if this value become numerator, become your n factorial. Yes or no? Because n to 1. Denominator, n minus r to 1. So that will become n minus r factorial. This will be your answer. Whenever you are arranging r objects out of n different objects, that will be n factorial by n minus r factorial. And this in mathematics, we write it by a symbol. And that symbol is called as the NPR. That symbol is called as the NPR. We write as a NPR. Am I clear to everyone? Please confirm everyone. Is it clear to everyone? Very simple things I'm doing, but believe me, only simple things work. NPR. So what is NPR? Actual meaning. NPR is a mathematical symbol which represent arrangement of n different object. This wording, remember, different objects into r places, are different places, means I cannot apply this if objects are not different. I cannot apply this if places are not different. So this is applicable only when objects, different objects, has to be arranged into different places. Now onwards, we can save our time for filling the object. We can use directly this. Meaning, if I say how many different word I can form, a 4-letter word I can form by using these letters. The 4-letter word I have to form means we are having 4 places. And how many objects are there? I'm having total 7 objects. 7 different objects, 4 different places, no restriction. Means this cannot be used for, it should be for free arrangement. If restriction is coming, you have to follow the basic pattern. For 7 object, 4 places, no restriction, we'll say 7p4 will be the answer. 7p4 will be the answer. Is this clear to everybody? 7p4 will be answer. Somebody having the problem with the rth place. That was the very simple way. Okay, I will tell. First place n way, second place n minus 1, third place n minus 2, fourth place n minus 3. So 100 place n minus 100 minus 1, 99. Am I right or not? So rth place n minus r minus 1. See, first means n minus 1 minus 1. Second means n minus 2 minus 1. N minus 3 minus 2, 1. 4 minus 1. So same way. I hope it's clear now. Right? So it's only for different object. Be clear, and different places must be there. Very small thing, but very dangerous. Believe me, I've seen so many students, 90% students, they do mistake in the NPR and NCR. It's a very simple logic you have to apply. It's for different object, fix in your mind. If it's the object, the identical or mixed, then you cannot use this. So I hope this point is clear to everybody. Now, next point, write it. I'm just giving as a point. Again, I'm saying nothing you have to remember. Just understand the things. Number of arrangement of n different objects taking r objects at a time when one particular object never come in any arrangement, never come in any arrangement, feel the question, visualize the question. Now, don't try to learn as a formula or something like that. There are n different objects. We are arranging r object. This line having a meaning, taking r objects at a time. That means they are saying how many places you have to fill it. You have to fill r places. N different objects we have to arrange. But there is a restriction. One particular object, which object I don't know, but one particular object never come in any arrangement. Are you getting? Suppose if I say that form 3-letter word, if A never come in any arrangement, if A never come in any arrangement, remove it, na? So do this one only. So here one particular object never come in any arrangement. So you have to do arrangement of how many object? I have to do arrangement of only n minus 1 object. And how many places? R places. The answer will be what? N minus 1 PR. I guess everybody understood this point. Is this clear to everybody? Again, it's not a formula. Understand the logic behind it. So everybody can please confirm, is it clear? An object, one particular object never come in any arrangement. To remove that object, no, why should we have take headache? That object gone. I have to do basically arrangement of only n minus 1 object. The answer will be n minus 1 PR. So this will be the answer. Next. Quickly keep on writing. Number of arrangement of n different objects taking r objects at a time r objects at a time when m number of particular objects never come in any arrangement. Exactly same in any arrangement. Means suppose 20 objects are there, 4 particular Chinnu Munnu is there which is not coming in any arrangement. So something like that. Answer you will type. I don't know. I forgot the P&C. Please type the answer. N object we are arranging into R places. M number of particular object never come in any arrangement. M number of particular object never come in any arrangement. Answer you have to write. Yes. None of it genius. I don't have to teach. Anyway, will be by M number not coming to throw them out. Na? N minus M PR. N minus M PR. Now the question which is I'm going to ask. Again, all these are the type of situation. And all the type of situation we'll discuss as like this. It will cover every type of situation. Next one. Number of arrangement of n different object taking r object at a time when one particular object always come in every arrangement. When one particular object always come in every arrangement. Can you give the answer? This kind of question in the first lecture we did, if you remember. That time we did by the basic method. Anybody can give me the answer of this question. N different object is there. I want to arrange only R object, but one particular object always comes. He said that, hey, I will be there. I will not go anywhere. I did not get answer. Till now, nobody given correct answer. because you are not using common sense, you are using mathematics. Use common sense. Watch it here. There are n objects and r places. How many places? R places. R number of places are there. Out of those n objects, one particular object says that ki I will always come in every arrangement. Whatever arrangement you do, I will come. So I will tell that person, first you go. That person will come out and he will arrange himself. One person, R places, how many way can be filled? R is the person, the particular person. Anyway, it may be here, he may be here, he may be he or she. Maybe here, maybe here, maybe here. So there are R ways are there to sit down for that particular person. So now, after doing this, I become confirm कि भाई चलो, now that person is there in every arrangement. Now balance how many places? R minus 1. And how many object? N minus 1, because one object already gone. So N minus 1 object and R minus 1 places. How many way I can fill? And balance can be filled by this way. And means multiplication. This will be answer. Please let me know, is it clear to everybody? Is this clear to everyone? See, as for example, suppose if I say using the digit 1, 2, 3, 4, 5, 6, 7, 8, 9. I want to form 4-digit number, but every number must contain digit 1. Every number must contain digit 1. I'm not saying it should start with 1. I'm saying it should contain 1. So I will tell to Mr. 1, please go and take your chair. So 1 can be placed in how many way? 4 way, and means multiplication. Balance 3 places. Which 3 places? I don't know, and I don't care also. And how many object balances there? Total 8 object balance. So we'll say 8p3. I hope it's clear to everybody. Now, but this question we can solve by other way also. Watch very, very carefully. Very important point. We are going to see it here. All the point what we are learning, that is important. We can solve this question by some other way also. What they are saying? Ki bhai, one particular object always has to come. The first thing, suppose I forget the condition. I want to arrange n different object into R places. I will say simply NPR. Yes or no? But I need that answer. Because in this answer, that particular object may come, may not come. So out of these many ways, number of ways, those ways I will remove where that particular object is not coming. So minus, in how many way I can arrange an object into R places so that a particular object never come. You will say, before this we did n minus 1 PR. Yes or no? One particular object never come. So that particular object, throw it out. So n minus 1 object R places, will say n minus 1 PR. I remove those arrangement. Whenever you want to remove arrangement, you have to subtract it. I am removing those arrangement. This is the total cases when that particular object is there as well as that particular object is not there. Particular object not there, I remove. So balance is this. That means this way also answer can be written. They both will be same thing. Answer cannot be different. So this will be 100% sure it will be equal to R into n minus 1 PR minus 1. And this gives us one identity. NPR always equal to n minus 1 PR plus R into n minus 1 PR minus 1. This is the one of the identity which can be. This is one of the identity which we can use it. NPR always equal to n minus 1 PR plus R into n minus 1 PR minus 1. Believe me, it's a help a lot when we solve big series. When I will teach you progression topic, their questions will come based on this property. You can derive this property by taking right hand side and expand in term of factorial, and then calculation do, you will get the same thing. But why should we do by that way? This is the best way. Is it clear to everybody? Is this clear? Can I go ahead? This as a property separately, you should this property you have to learn it. No other choice. You should remember always. Okay, NPR we can write in terms of n minus 1, and that is the way it has to be written. Sometimes direct objective question used to come on the base on this property. So when we'll do series based question, I will show you the use of property. But till that time, you have to remember this property. You say, sir, by that time, who will remember? You have to remember. As I told you that you have to make your white paper, and this has to be there. These are the main property which you may forget. So it has to be remembered. Chaliye, next case. Number of arrangement of n different objects taking all at a time when m number of particular objects always comes together. This line, understand. It will be asked you in different way. Question will be asked to you different ways. Before you give the answers, let's do some other question. Stop writing, concentrate. Suppose I want to make a 6-letter password, 6-character password. Later I should not say 6-character password using A, B, C, D, E, F, G, H, 1, 2, 3, 4. Sorry. A, B, C, D, E, A, B, to A, B. Yes. Yeah, this many only. You say very weak password, sir. No, we are not going to check Googling out. Means we are not making Google password. So weak and strong doesn't matter. A, B, 1, 2, 3, 4, we have to make, using this, I have to make a 6-letter password. Condition is that in every password, only this letter you have to, this character you have to use it. This character only, okay? Only one time. In every password, letters should be together. Letters should always come together. Did you understand my question, everybody? All the letters, only 2 letters are there. They should be always together. Togetherness in the object. This is the condition. This is called the restriction on object. What is the restriction? Ki those two objects, these two objects, A and B, always want to come together. Am I clear to everybody? Watch it. Watch carefully, everybody. Suppose if I say, in how many ways I can arrange all these objects, taking all together, you'll say 6 factorial. By 6 objects, 6 factorial. If I have to arrange them, whoever want to come together, keep inside them in a box, imaginary box. Real box is not there. One box. and assume this box as a single object. This box as a single object. Why? If it's a single object, wherever is going, they will be always together or not. By arrangement means what? When I say arrange letter A, B, C, please listen carefully, everybody. Those who know the answer also, then also listen. Arrange A, B, C. You'll say, sir, 3 factorial means 6 way. If I say no, manually arrange it. So what do you say? A, B, C, A, C, B, B, A, C, B, C, A, C, A, B, C, B, A. Actually, arrangement means what? Interchanging of position. Arrangement means what? Interchanging of the position. We are just interchanging. See, A, B, C. The next arrangement, how I got it? B and C interchange their position. We got a new arrangement. So I have to use all these 6 characters to make a password. But A and B should be together. I know that they can interchange their A can be interchanged with the 4. I don't want that. So what I said, for completely I said that they are inside a box. Now arrange them. How many object is there now? 1, 2, 3, 4, 5. Because box is a single object. So 5 factorial I can arrange. Up now, this box is shifting here and there going. So A and B are together or not? Yes or no? A and B are together. If A and B are together now, to our purpose solved. But there is a problem. They say that key letters should be together. They did not say that key letters should be in the order A, B. So here they can do internal arrangement. Internally they can interchange. In how many ways they can internally arrange? 2 objects, 2 places there. So 2 factorial into 2 factorial. This line everybody understood. Is it clear to everybody this line? Quickly response. Is it clear to everybody? 5 factorial into 2. 5 factorial, how it came? Because total object 5 is there. So that can be arranged by 5 factorial into internal arrangement. The wording, remember what I'm saying, it's going to use future. Internal arrangement means whoever inside the box, in how many ways they can do internal arrangement. Think, if anybody asks, in how many ways do ABC can do internal arrangement, means interchanging of the position, that is the 3 factorial. In how many ways ABCD can do internal arrangement, 4 factorial. Correct? Now imagine another question, everyone, please. In using these letters A, B, C, D, E, I, O, in how many ways we can arrange so that key using all the letters, so that key vowels are always together. So that key vowels are always together. See, I'm doing vowels are always together. Make a box and dump all the vowel inside this box. A, E, I, O. I hope vowel everybody know na? B, C, D. These 3 left. So now how many objects? 1, this is a single object. 2, 3, 4. So this can be done into 4 factorial way. This is the arrangement of this box, moving box here and there. Now inside the box, they can play the game. In how many ways they can do internal arrangement? 4 factorial. Hello. Is this clear? The next question you are going to tell. In how many ways we can arrange this so that vowels should be together as well as consonant to be together. Means vowels should be together as well as consonant should be also together. Answer me. Vowel should be together as well as consonant should be together. Vowel should be together as well as consonant should be together. Everybody. Yes, very much correct. So many people giving the answers. I'm happy. Now vowels should be together. One box. One more box is needed. For consonant should be inside the box. Now, how many object? Only two object. Only two object because box is the object. So 2 factorial they can be arranged into internal arrangement of this first box 4 factorial into internal arrangement of the second box 3 factorial. I'm sure able to understand everyone, right? Now this question everyone can give me answer me. In number of arrangement of n different object taking all object at a time when m number of particular object always comes together. Only one student give an answer. I'm not sure it's correct or wrong. That we'll see later. Let other people please speed up. Fast, fast, fast. Okay. Let's see. Very, very simple. First thing, m object want to come together, remove those and keep inside the box. M. How many object left? N minus m object left. Are yes or no? This is the number of object. Be clear. This is the one object. This is the one object. This is the n minus m object. The total number of object will be n minus m number of object plus one box. One. This arrangement first I will do into internal arrangement of this box m factorial. This will be the answer. So simple. Am I right? Now, watch it. Before going to the next point, I wanted to do one as a question. One simple question. Answer me, everybody. There are, as I'm asking question, immediately answer. A very simple question. I never ask tough question, you know it. There are 10 objects. 10 objects and 4 places. No condition, no restriction, free. All 10 different objects. I'm talking only different object and 4 different places. In how many way I can arrange it quickly? In how many way I can arrange it? How many way I can arrange 10 different object into 4 places, everybody? Typing this much time it take. ये कौन है भाई 10p3 who is saying 10p3 नालायक अरे 10 object are places npr means 10p4 very simple no doubt about it no confusion it is something like that ki there are 10 people a1 a2 whose name is a1 a2 a10 and there are 4 chair 1 chair 2 chair 3 chair 4. In how many way we can arrange? We can say there are the 10p4 way is there. A1, A2, A3, A4, or maybe A2, A3, A4, A5, and so on. Now, changing the question. This time, 4 object is there. And 10 places are there. In how many how many way I can arrange four different objects into 10 places. Did you understand my question? Four objects into 10 places. Of course, all 10 will not be filled. So how many different arrangement I can show? Again, same thing. It will be 10 P4 only. Think carefully why. First, let's do the previous question here first. Manually, 10 object, 4 places. Very important point. Please listen carefully. 4 places, 1, 2, 3, 4. So this place can be filled by 10 way. This place can be filled by 9 way. This place can be filled by 8 way. This place can be filled by 7. Correct? Because every place will be filled. So answer will be 10 into 9 into 8 into 7. I'm not writing full answer. Now come to here. I'm having 10 places. Watch it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think 10, 3, 3, 6. Yes. Now 4 objects. Now places is more. So we don't have to fill the places. We don't have to fill the place because we cannot fill. I will tell first object, please go and take your chair. So first Chanku will say, I can take my chair by 10 different way because all are empty. Second person will say, I will take my chair by 9 way. Third person will say, I will take my chair by 8 way. Fourth person will say that I will take my chair by 7 way. Look, both are same. Both are same. What I am trying to teach you from this point, NPR, it doesn't mean n object and r places. It can be there are n places r object. Whoever is bigger, they will come in superscript here. Did you understand this point? Is this clear to everybody? Am I clear to everyone? 10 object into 4 places will be 10 P4. Or 4 object into 10 places is same. So that will be NPR only. No difference. This point always keep in mind. NPR condition is that n should be always greater than equal to r. That's the most important condition. It does not matter who is the object and who is the places. Now coming to the original question. In how many ways six boys and 5 girls can be arranged in a row? Can be arranged in a row. Means everybody is going to get arranged. So that first bit, all girls are together. Type the answer of this bit. Then second bit I will talk. For this bit answer, six boys, 5 girls, I want to arrange in a row so that all girls are together. We did already this kind of question, right? Yes, I guess everybody got the answer. All girls are together. Girls will go inside the box. Be clear, it's not real box, it's imaginary box. So that will total object will become 7. So that will become 7 factorial into internal arrangement of those 5 girls into 5 girls. Right? Now, next. No two girls are together. No two girls are together. Can you understand the difference between these two questions? Any two girls should not be together. No two girls are together. Very easy if you use little bit common sense. No two girls are together. Hey, some people are giving answer two. This country don't have any future. Chalo. Let's understand meaning of the question. No two girls means there is a restriction on this group of objects. There is no restriction on this boys. So let the arrange the boys first. B1, B2, B3, B4, B5. Yes or no? Boys can be arranged in how many way? I will say 6 factorial. Sorry, B6. 6 boys are there. Yeah. 6 factorial. Boys can be arranged in 6 factorial. Everybody agree with this me? 6 boys, no restriction. Anywhere they can be. 6 way they can be, a 6 factorial way they can be arranged. Now I want to arrange the girls. But girls having restriction. Where girls can come? Girls can come here. Or girls can come here. Or girls can come here. Or one girl can come here. Or maybe here, maybe here. I'm not saying everywhere girls are there. Girls are only 5 girls are there. These are possible positions. If you put girls anywhere on these places, they will be not two girls will not come together. Everybody understood my point? Suppose you say, sir, 5 girls are there. Suppose here I put, here I put, here I put, here I put, here I put. But here I didn't put. So they will, boys can come together. If these two places girls are not there, means these two boys are together. So boys can come together. I didn't put the condition for the boys. Girls' places is only these places. So how many places for the girls? Total, there are the 7 places because 6 boys. So between them 5 gap and 2 extreme, 7 places. In that 7 places, we have to arrange only 5 object. Places 7, object 5. So into 7P5. Can everyone confirm? Is it clear? Is this clear to everybody? Everyone, please confirm. Is it clear? This is actually, some books used to call it as a gap method. No gap. Previously, when this is called the string method. I'm just writing by chance. If suppose somebody say use string method, you say, don't say, sir, you didn't teach it. It's not. It's just name given by some book authors and all. Mathematics doesn't have this kind of the name. Gap method, why say that? Because there in the gap between whatever gap is there between boys, we are filling it. That's all. I'm sure it's clear to everybody, right? So this is gap method, which will try to generalize the situation and will see the things. So for today's, this much is enough because only I'm having class till 7:45. So we'll continue in the next lecture. And next lecture, I guess, permutation part will get over. But again, I'm saying, do not learn any formula, understand the logic properly. So please revise those questions which we discussed in the class today. Try to resolve those questions again, once again. It will give you confidence. And you can start now doing NCRT. First NCRT, do not touch any JEE book. Do not solve any JEE question. Only NCRT and do logically. Right? So we'll continue in the next lecture. Thank you very much to all of you. Any doubt and all is there, you can ask me. Thank you.